Claude has had for a long time since Claude 3 back in March, the ability to analyze images and respond to them with text. Anthropic has come up with a new way to study how big language models such as Claude process information and make choices. This method allows researchers to better understand the thought process of these AI systems, unveiling previously undiscovered insights. Today, new research has been released in 2 papers demonstrating that LLMs are more sophisticated than previously thought. These models are able to think ahead when writing poetry, use a similar process to understand ideas in multiple languages, and sometimes start from the end goal instead of just following facts sequentially. Drawing inspiration from methods used in neuroscience to study the human brain, this new approach is a significant advancement in making AI more understandable. It has the potential to uncover unseen dangers in AI systems that may not be easily identified through traditional testing. By examining the inner workings of the model, researchers can gain a clearer insight into how these systems learn and improve their skills. Joshua Batson, a researcher at a company called Anthropic, said that even though AI systems are very smart, it's hard to know exactly how they learn. He pointed out that AI models are basically just a bunch of numbers in a neural network, but this new approach helps us figure out how these numbers interact, giving us a better understanding of how AI works. This finding has the potential to create AI systems that are safer and more dependable, as well as influence the future of artificial intelligence. What exactly are these new discoveries, and why are they raising terrifying questions? Let's dive in. The way I think of computer use, which is what we call that capability, is I think of it as the first step towards a broader vision unlocking the mystery inside AI models. Large language models such as OpenAI's GPT-40, Anthropic's Claude, and Google's Gemini are extremely advanced. They can do things like write code, summarize research, and have complex conversations. Despite their impressive abilities, even the people who made them don't fully comprehend how they work. Anthropic has come up with a new method to analyze these models known as circuit tracing and attribution graphs. These procedures help researchers track the specific routes that are activated when an AI processes data. This advancement is significant as it provides a better understanding of the thinking process of these models. The method is based on studying how the human brain functions, which is inspired by neuroscience. Like how scientists analyze neural connections in real brains, researchers at Anthropic can now observe how artificial intelligence creates thoughts and decisions. This changes a previously unknown process into something that researchers are able to examine. Scientists can now explore important questions about AI thanks to this progress, such as whether these models are actually thinking, planning, or simply regurgitating information. Knowing how these models function on the inside could result in AI systems that are more transparent, dependable, and secure in the future. How Claude understands different languages. Rather than considering English, French, and Chinese as independent languages, the model converts thoughts into a common abstract form before giving a response. This implies that Claude doesn't just memorize words in various languages, but comprehends ideas at a more profound level. Researchers discovered something interesting when testing how Claude identifies opposites. It was found that regardless of the language used, Claude activated the same internal features for concepts like opposites and smallness, when prompted with the opposite of small. This indicates that Claude operates by working with universal ideas, and then translating them into the appropriate language. The finding has significant consequences for the advancement of artificial intelligence. It suggests that language models can more effortlessly share knowledge between different languages than previously believed. For example, if a model learns a concept in English, it might be able to use that knowledge in French or Chinese without requiring full retraining. As artificial intelligence models become bigger and more sophisticated, they appear to gain a better grasp of language that is not specific to any particular language. This may result in more precise and natural translations, improving the efficiency and smoothness of AI communication between different languages. Aside the way it understands different languages, what other shocking discovery has been found about AI? How AI thinks ahead? A look inside Claude's mind. Claude has a unique skill of planning ahead when writing poetry. Instead of randomly generating words, it selects a rhyming word before starting to write the first line when given a prompt for a rhyming couplet. This ability to think ahead impressed the researchers at Anthropic. The model prepares to write a poem that ends with the word rabbit by activating related features in its process. It constructs the sentence in a way that leads up to the word rabbit in a logical manner, This shows that the model doesn't just randomly put words together, but actually plans its output deliberately. Researchers discovered that aside from creating poetry, Claude also demonstrates real multi-step reasoning. For example, when asked about the capital of the state where Dallas is located, the model first realizes that Dallas is in Texas. It then uses this information to correctly identify Austin as the answer. This indicates that Claude is not just regurgitating memorized information, but is actually processing information in a logical and sequential manner. Researchers decided to test this out more by changing Claude's mental representation from Texas to California. The model then gave a different answer, Sacramento, showing that it doesn't just remember answers but actually thinks logically. Ever notice that AI would never tell you that they lack detailed information about something? Rather, they would give you an answer, sometimes incorrect. Well, here is the reason why. The hidden cause of hallucinations. AI models like Claude often struggle with making up information when they are unsure of the answer, a phenomenon known as hallucination. This has been a source of confusion for researchers for a long time now. Now, Anthropic has discovered a significant factor that contributes to this issue. Claude has a feature to prevent it from answering questions when it doesn't know the answer, but if it recognizes a name or topic, it knows it can still respond. This usually works, but sometimes Claude will still give an answer, even if it doesn't have the right information. This is why AI models confidently give wrong information about famous people or topics, but won't answer questions about less popular subjects. When the model comes across something it recognizes, it thinks it should know the answer and provides information even if it's incorrect. The hidden flaws in Claude's reasoning. One more worrying thing we found out about Claude is that its thinking doesn't always line up with what it says. In difficult math problems, like finding coin values of big numbers, the model may act like it's using logic, but its actual process is different. Instead of doing the calculations, it sometimes makes up an explanation that seems right. Researchers discovered that Claude approaches problem-solving in three distinct manners. At times, it follows a logical sequence of steps. Other times, it creates a logical-sounding chain of reasoning that may not be connected to the truth just to seem convincing. Sometimes it starts with a provided answer and constructs an explanation to fit that answer rather than solving the problem on its own. If a user gives a suggestion for a difficult question, Claude might use that suggestion to come up with a possible answer by creating a reasoning path to explain it. This shows that the model doesn't always rely on basic principles to reason. It can be impacted by outside ideas. The results indicate a big problem in creating AI. Even though AI models may seem very smart, they don't always think the same way humans do. Recognizing these limitations is important for creating AI systems that are dependable and trustworthy. So what are the possible solutions? A major step toward transparency. Anthropic's newest study comes at an important moment as worries about the transparency and safety of AI are increasing. With AI becoming more sophisticated and prevalent, it's crucial to comprehend its inner workings for trust, security, and dependability. Without a solid understanding of how AI functions and makes choices, there are potential risks for users and businesses when AI provides inaccurate or deceptive answers. This study has made a significant discovery that could impact our interactions with AI by examining how models like Claude think. Experts can pinpoint mistakes in logic, monitor how decisions are made, and stop potential problems in advance. This is crucial because companies are using advanced language models more and more for things like customer support, data analysis, and automated tasks. Understanding when and why these systems might give wrong information is key to lowering risks and enhancing AI effectiveness. Anthropic has always highlighted the significance of AI safety, aiming to avoid unfair biases, promote transparency, and minimize the risk of misuse. Previous research by the company delved into ways to monitor AI's actions, detect misinformation, and steer it towards safer and more ethical decisions. The most recent discoveries expand on this concept by providing more detailed understanding of how AI analyzes information and how its reactions can be shaped by various inputs. One exciting potential of this research is that it can help AI systems become more transparent by tracing circuits. Scientists can visualize how an AI model thinks, similar to how early scientists drew diagrams of the human brain. This allows them to understand which pathways the AI uses when answering various questions, but this process is still at an early phase. These techniques only offer a glimpse into some of the model's inner workings, and fully grasping how AI decides things is still a difficult task. Despite its limitations, the study is a big step towards making AI systems safer and more dependable. AI models like Claude show they can reason with just basic prompts, which researchers are still learning about. Scientists want to improve AI accuracy, decrease mistakes, and make sure these systems behave the way humans expect by enhancing investigative techniques. As AI technology improves, it is important to make it more understandable to ensure safety and gain trust from the public. The information obtained from this study could influence the creation of rules and technological protections to keep AI helpful and not harmful. Even though there is a lot of work to be done, these results are a significant step towards achieving AI that can be easily explained. If you've made it this far, let us know what you think in the comment section below. For more interesting topics, make sure you watch the recommended video that you see on the screen right now. Thanks for watching.